In this problem we have to find the equivalent capacitance between point A and point B. So I redraw the circuit like this. These three capacitors. In this particular problem their capacitance is taken same, but it might be different. Suppose I take them C1, C2 and C3, and we have to find the equivalent capacitance between A and B, and they are connected like this. I'm telling you these three capacitors are connected in parallel, but I have to show how they are connected in parallel. So this is point A, and the potential of this point is VA. Since this point has same potential VA, and this point will also have the same potential VA because it is connected by a wire. So if I names these plate numbering of this capacitor, plate number 1, 2, 3, 4, 5 and 6. So potential of plate 1, 4 and 5, all these three potential, I mean 1, 4 and 5, will have same potential as A, and that is VA. Similarly the potential of terminal 6 and 2 and 3, 6, 2 and 3 will have same potential as VB. So we can say the potential of A, point A, I mean A is connected, I can say, as three plates: plate number 1, plate number 4 and plate number 5, and plate 1 makes capacitor with plate 2, plate 4 make capacitor with plate 3, and plate 5 makes capacitor with plate C, and 2, 3 and 6 have same potential as point B. I mean we can represent these three and connect them as a point B. So we have three capacitor in parallel, and this is C1, this is C2 and C3. So we CAB equal to C1 plus C2 plus C3. In this problem we have to find the equivalent capacitance between point A and B. We see this particular capacitor is between point A and B and connected directly between these 2 points, and we have 1, 2, 3, 4, 5 capacitor. Generally 5 capacitor makes Wheatstone bridge. So if I remove this particular capacitor and see what happened to the circuit, and we connect it later in our circuit. So I redraw it. So this is point A and this is point B, and if I take this point here, I mean I want to switch over, I mean flip over to this side of this capacitor. It looks like so. it looks like a balanced Wheatstone bridge. And as I have removed this particular capacitor earlier, now I can connect it between point A and B. So this become very easier. This is balanced Wheatstone bridge, and in balanced Wheatstone bridge this is diagonal capacitor which can be removed, and the circuit will becomes like this. This is point A, this is point B, and there is capacitor. So all being equal capacitance C. So these two will be in, these two capacitor will be in series, and these two will be in series, and this and all three branches will be in parallel. So we can write it as this is C by 2, this is A, this is B, and here it is C by 2, and there is another capacitor C. So their equivalent will be CAB equal to C by 2 plus C. This will be equal to 2C. I will take the first circuit here. I am going to redraw the circuit. So first one is like this. This is point A and this is point B, between which we have to find the equivalent capacitance. All the capacitance, the problem is all the capacitance have same capacitance C. So these all have the same capacitance C. Now how to find the capacitance C? This point is actually point A, and it is directly connected by wire to this point, so this must be also a point A. Their potential will be same. In many cases we can reduce a connecting wire, its length we can reduce, so we can connect this point directly to this point and see what happens to the circuit, and this is much easier way to solve. So this length is straight like this, and this point, I mean this capacitor is made here like this, because I have taken this point here, and this one which is connected from this to A, I mean this, so we can write like this. So this is A and this is B, and its capacitance is C, So these two capacitors are in parallel, their equivalent capacitance will be 2C. So I can write like this. This is 2C, this is C, and we have here C, A. Now these two capacitors are in series, so their equivalent will be, I mean 2C into C upon 3C, 2C by 3, and 2C by 3, 2C by 3 is in parallel with this capacitance, and this is A and B, and these two capacitors are in parallel, so their equivalent will be CAB will be 2C by 3 plus C, 5C by 3. So this is their equivalent capacitance. Now I'm going to take this this circuit, the other one, and it will be solved in the similar manner. Now see, we have to find the capacitance, equivalent capacitance between point and A and B. Again I am going to redraw the circuit. So this is the original circuit given to find the equivalent capacitance between point A and B. So this is the point. Always keep in mind that about which two point we have to find the capacitance. So this is A and this is B. Now these 2 points is simply connected by a wire, so their potential will be same. So this point is again A, and similarly if this is B, so this point will be also B. Or we can say, if this wire is connected here, we can connect it here as well. Similarly, if this is connected here, we can connect to A directly. I mean, I can redraw like this. So this capacitor, this capacitor which is connected from this to this, can be connected now like this. Sorry, this is point B, and this capacitor which is connected to this, but now it can be connected here because the potential of this point and this point is same. So again, the number of capacitor is same. I simply draw a new circuit, a simpler one, which can easily recognize as a series of parallel. So these two capacitor are in parallel, so we can, this is point A, we can again redraw this is 2C, C, this is point B, and here it is 2C and C, and this is point A. So these two capacitors are in series and these two capacitors are in series, so their equivalent will be how much? 2C by 3. So their equivalent 2C by 3, and these two branches are in parallel. So equivalent CAB equal to 2C by 3 plus 2C by 3, 4C by 3. So this is the equivalent capacitance between point A and B. So we have 4 plate, and we have, and the plate area is A, let's, and separation between two adjacent plates is D. So C is the capacitance between these two plates, and it will be equal to epsilon naught A by D. Now first of all, how these plates are connected is given in the question, that these two plates are connected and its name is A, and these two plates are connected and its name is B. So we have 3 capacitance between the adjacent capacitor plates, 1, 2, 3, and we are going to name the plates, like this 1, 2, 3, 4. But This will not make a capacitor because both plates are connected to a same point, so potential difference between these two plates will always, the potential difference will be zero, I mean same potential of the both plates. So this there will be no charge between these two plates, no energy will store. So there is only two capacitor formed here, this one and this one. We have to see whether they are connected in series or parallel. So plate point A is connected with 1 and 4, so I can make like this: plate 1 and plate 4 is connected to A. Plate 1 makes capacitor with plate 2 and plate 4 make capacitor with plate 3, and 2 or 3 are joined and designated as point B. So we have two capacitor, and as I've told you, the capacitance between two adjacent plates is C, and all the capacitor is C because the separation and the plate area in all cases is same. So this is C. So CAB will be equal to 2C, I mean 2 epsilon naught A by D. Let's see what will happen in that case. I mean in that case how the plates are connected and what will be their equivalent capacitance. We are going to see this one. So again we will name the plates. Let's draw the plate first. Again here are 4 plates at the same separation and plate area. So this is plate 1, plate 2, 3, 4, and 2 and 4 are connected to point A, and 1 and 3 makes point B. So there are 3 capacitor like this: C1, C2, C3, and C1, C2, C3 all equals to epsilon naught A by D. We can also write as C. So I am going to redraw this circuit as this is point A and it's connected to 1 and 4. So I make plate 2, sorry, A plate is, point A is connected to plate 2 and 4. 2 and 4. Now plate number 2 makes capacitor with plate 3 as well as 1. So here I makes plate 1, and plate 2 I have to redraw again because it makes capacitor with plate number 3, and 4 makes plate number 3, and these all points are connected as point B. So all the 3 capacitor which are here same, identical. So CAB equal to C1 plus C2 plus C3 equal to, I mean if they are the same, 3 epsilon naught A by D, or we can write as 3C. So this is for now I'm going to redraw the circuit as this is plate 1, 2, 3, 4, and these are connected to B, and these connected to A. Now when a battery is connected to point between point A and B, there will be no energy stored in between these two plates because they are at the same potential. You know, Q is equal to CV. V here is potential difference. If there is no potential difference, no charge will be stored. Now Similar case is with this. So these two capacitor, there will be no capacitance between these two, only this one. So capacitance between A and B will be only this one, and it will be equal to epsilon naught A by D. Though there will be no energy stored, there will be no energy stored here or here, only this will be a capacitor. So only single capacitor will form here. 1 2 3 4, there's 5 plates. 1 2 3 4 5. Let numbering it. 1 2 3 4 and 5. Now these two plates 1 and 3 are connected, and its name is A, and plate number 2 and last one 5 is connected as a point B. Plate number 4 is not connected to anyone. Now we have 1 2 3 4 capacitors here, and its capacitor is C equal to epsilon naught A by D. So I have to see in what way these 4 capacitors are connected. So I'm going to redraw the circuit. This is point A, and is the two plates are connected to A, that is plate number 1, which make capacitor with plate 2. So this is 2, and it is plate number 3, which is also directly connected to A, and it make capacitance with plate number 4, and 4 is connected. 4 again make capacitance with 5. So here I draw 4, and it make capacitance with plate number 5, and 5 is connected to B. So 5 and 2 are connected here, and A is connected to 1 and 3. Now 2 is connected to B, so I can write like this. So this is point B. Now we have 3 capacitor arranged here, but they are 4 capacitor. So 1 and 2, this is arranged, are connected here. 3 4, yes, it is done, and 4 5, yes, but 2 and 3, so 3 is here and 2 is here, so I have to draw again 3 and 2. So I can draw it here, or we can connect to 2 like this, all the same. So C, their capacitance is C. These two are in series, and we have 3 branches in parallel, so we can write this like C, and their equivalent will be C by 2. So this is C by 2, and these 3 are in parallel. This is B, this is A. So CAB will be equal to C by 2. This is 5C by 2. I mean 5 by 2 epsilon naught A by D. So this is their equivalent. Again here we have to calculate the equivalent capacitance between point A and B. We have 1 2 3 4 5 plates. I have to draw it here. 5 plates. 1 2 3 4 and 5 plates. Let's numbering it. 1 2 3 4 and 5, and plate number 1 and 4 are connected as a point A, and this is plate number 5, and second connected as B. So we have 1, 2, 3, 4 capacitor formed here between these plates, and we have to look for in what way they are connected. So terminal A is connected to point 1 and 4, and B is connected to 5 and 2. So read write A. This is A. It is connected to plate number 1 and 4, and 1 makes capacitor with 2, and 2 is connected to B. So I will make it B here, and 4 makes capacitor with 5, and 5 is also connected to B. So we can make like this. This is B. So 1, 2, this capacitor is used, 4, 5, this capacitor is used, and between 2 to 4. So I have to draw 4, plate number 4. 4 make with plate number 3, and 3 is not connected to anyone, but it forms capacitor with plate number 4, and 3 makes with plate 2 as a capacitor, and 2 is connected to B. So I can write like this. So C, 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 C. Now this can be written as C, C, and this is C by 2. This is point B, this is point A. So CAB will be equal to C plus C plus C by 2, 5C by 2. One more thing, if we have plates like this, I want to tell you that if we have so many plates, suppose like this, and this is A and this is B, and this plate between is not connected to anyone, suppose this is 1, 2, 3, 4, 5, 6, we can arrange like this. This is 1 make with capacitor 2, 1 make capacitor with plate number 2, again draw 2, it make capacitor with 3, again draw 3, it make capacitor with 4, again draw 4, it make capacitor with 5, again draw 5 and make capacitor with plate number 6 which is connected to point B. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 capacitor in series, and so this same idea is used here for this plate number 3. So there is a capacitor between 2 and 3 and in series with capacitor between plate 3 and 4, this and this. So this you have to keep in mind. We have to find the equivalent capacitance between point A and B. We have 1, 2, 3, 4, 5 plates. Let's draw it. 1, 2, 3, 4 and 5 plates. Name it 1, 2, 3, 4 and 5, and 1 and 5 are connected as a point A, and point plate number 3 is point B. So we there will be 1, 2, 3, 4 capacitor will be formed, and each capacitance will be epsilon naught A by D. So we have to see in what way these plates are connected to form the capacitor. So point A is connected to plate number 1 which form capacitor with plate 2, and 2 makes capacitor with 3, and 3 is point actually B. Again A is connected to plate number 5. 5 make capacitor with plate number 4, which makes capacitor with 3, and 3 is actually connect 3 is point B. So we have got 4 capacitor here, 1 2 3 4, and 4 capacitor. So this capacitance will be C, and this can be written as CC, and there's CC, and this is point B, it's point A. These are in series, and both are in parallel, so this can be written as this is C by 2, this is C by 2, and these are in parallel, so their equivalent will be CAB equal to C by 2 plus C by 2, C, which equals to epsilon naught A by D. So this is the equivalent capacitance between point A and B.